All right, if we want to find the sum of an infinite series, we can do so if the rate is less than 1. If you remember from different things that we've looked at this year, if our rate is less than 1, we would know a sequence or series is converging to a value. Specifically, it'll probably be converging to 0, most likely. So what that means is if we have an infinite series, we could predict what the infinite sum would be because the last values will be all like adding zeros. So we could find it. So here's our formula, a sub 1 over 1 minus r. This only works when the absolute value of the rate is less than 1. So it could be negative, it could be positive, that's fine. But it simply put, the absolute value of the rate needs to be less than 1. Let me show you if it's possible here. So we take our second term, divide it by the first term, and we find out that 18 divided by 24 is the same thing as 6 goes in both into these 3/4 or 0.75. Since this is less than 1, we can find the infinite sum. And this is since I should have here. And I'll make this easier to read. Okay, so what do? So the sum, and you don't put a number down there, you don't have to put infinity. If you just did capital S, that means the infinite sum is your first term, which, remember, this is the a sub 1. So you'd put 24 over 1 minus our rate, which was 0.75. Now, you might know that that's a quarter right there, but I'll go ahead and type it in the calculator just like that so we don't make any stupid mistakes. So I take my 24 and put it over 1 minus, and my rate was 0.75. When I hit enter, it tells us that our infinite sum is 96 here. And so we have now our answer of 96. That means if you added up the infinite amount of this series, it would add up to 96. Just think 24 plus 18 gives us 42. When we add this one, we get 55.5. So we're on our way, but it'll approach 96. That's what it'll approach. All right. So now, if possible, find the sum of this sequence. Now, so again, we do the same thing. We take the top term, and since it's geometric, I'm dividing. Remember, if it was arithmetic, we would be adding or subtracting. And we find out that this, when we divide, is 2. This one, we cannot find the sum because the rate is increasing. All right, so this one is not possible. It's not possible simply because that rate is too great. It would be not converging to a value, it would be diverging. So it would approach, this one looks like it would approach positive infinity as we add them all together. So this is just simply not possible. All right, so now this time, so we're wanting to find the infinite series, the infinite amount, and yes, we can do it because why? This rate is less than, the absolute value of the rate is less than 1, so it is possible. Now again, our calculators don't like to find this. Just as a point out, this is the first term, this is the rate here. So the calculator won't work if you try to do this. The calculator has this overflow, so remember sigma is over here next to 9. We hit that button. We say from when n right here is, they actually didn't start at 1, did they? They started at 2. And we could put an infinity up here. Oh, so sorry, infinity is with the pi button. There's infinity. We could put that there, but you'll see that this won't actually work out. Was it 0.65 to the power of n minus 1? We press enter, it'll say overflow, or I'm sorry, unsupported feature. It doesn't go like that. So one thing you can try, if that doesn't work, is you can pick a big number, like say 1,000, and try that. But what we'll do is just use that formula. So we're going to change it and say s equals a sub 1, which here, this is a sub 1, over, oops, a sub 1 is 3, over 1 minus our r, which in this case, our r is 0.65. And so we type this in the calculator. 3 is the first term, and this is 1 minus 0.65. And so we'll take this, screen capture that, move it over. And so if we're not careful, we'll think the answer is 8.57. I'll round to the nearest hundredth. That's not actually accurate because we want the sum of the terms from 2 on. We don't want the first term. So I actually need to subtract a sub 1, which, if you remember, a sub 1 is the value 3. So I'm going to subtract a sub 1, and this will say that the sum from n equals 2 to infinity would equal 5.57. That's actually going to be our answer because we do not include the first term. Okay, so that's what that's a little tricky on this one. So your turn to find this out. Luckily for you, you're starting from 1, so you won't have to do any special tricks.